In this video, we're going to talk about some of the background science behind why the rate of cricket chirping is related to temperature. And we're going to talk about some of the lessons I learned while trying to test this and try to figure out this particular relationship in the backyard. So, let's get to it. Many people are under the impression that crickets chirp by rubbing their legs together. That is, however, incorrect. What they actually do is rub their wings together. One wing has a couple hundred ridges on it, kind of like a comb or a file or something like that. And they then rub that wing against the other wing, or sort of scrape it. And that's what produces the sound. Furthermore, they sort of lift the wings up a little bit to form a chamber underneath, and that chamber helps amplify the sound. So let's go look at that previous clip again, and you can see what I'm talking about. So only males actually chirp. And they seem to do this primarily to attract females, but possibly they're trying to scare off other males from their space, or maybe there's some danger nearby or something else. We don't always know exactly what they're trying to communicate. You can tell a male from a female because the male, if you look at the back end, they have two appendages that sort of form a U or V-shaped. Females also have these two appendages, but in between them is another structure called an ovipositor. It's a very long, thin structure, and she uses this to lay eggs. You may be wondering, what does temperature have to do with any of this? Temperature matters because the rate of chirping is dependent upon the rate of muscular contractions within the wings. The rate of muscular contractions is dependent upon the rate of chemical reactions, and the rate of chemical reactions is dependent upon temperature. In other words, at cooler temperatures, chemicals react more slowly. At warmer temperatures, chemicals react more quickly. As these chemical reactions, or as these chemicals react more quickly and the rate of chemical reactions increases, the rate of muscular contractions increases, and hence the rate of chirping increases. All of it is related to temperature. Furthermore, this relationship between temperature and rate of chirping seems to work best in crickets between around 50 degrees and 85-90 degrees Fahrenheit. Above and below those temperatures, this relationship as laid out in Dowers Law seems to fall apart to some degree. So it's most accurate within that particular temperature range, although I didn't actually test this personally, particularly the upper end. There's a bit of a history associated with Dowers Law. It was first published in 1897, and it was basically the first formulation of this relationship between temperature and the rate of chirping in sort of an equation like that. So that's sort of why he gets the particular credit for this. But he is not the first person to have noticed this or even talked about it. There was a previous publication in 1881 by Margaret Brooks. What she did is she went out and tested this relationship. But she actually heard about it from a friend, sort of forgot about it, but then read about it again in the newspaper Salem Gazette, written by an article by a WGB. We don't know exactly who this WGB is. Their identity seems to have been lost to the mist of time, but basically a lot of people were apparently talking about this in the late 1800s, and it's actually unclear who actually discovered this relationship. Dowers Law has been modified over time. If you go back to the original article and look at the equation provided there, do a little bit of algebra, you come up with counting the number of chirps in 15 seconds, adding 40, and then that gives you the temperature. But over time, and I don't know exactly who or why, it has been tweaked. So you will see different variations of this. For example, you might see that you count the number of chirps in 15 seconds and then add 37, or you count the number of chirps in 14 seconds and add 40. I played around with all these different variations, and I basically found that if you count the number of chirps in 14 seconds and add 40, that gives you the most accurate temperature reading. This can also be done in Celsius as well as Fahrenheit. So if you count the number of chirps in 8 seconds, add 5, that will give you the temperature estimate in Celsius. Although I never actually tested this particular variation of the formula. Dowers never actually specified which species of cricket he used when he wrote his paper. Many believe it was something called a snowy tree cricket. In this yard, most of what we have are field cricket, which is a fairly common species, but there does seem to be a smattering of striped ground cricket and bush crickets. If you happen to have a better identification for any of these crickets, please leave a comment down below this video. One important item is to make sure the thermometer is as close to the cricket as possible without actually scaring the cricket. And I learned this through a rather interesting experience where a cricket was telling me it was 80 degrees, but my thermometer was saying it was 60 degrees. And I couldn't figure this out until I realized that the cricket was actually here in the garden, exposed to the sun and being warmed in the sun, while the thermometer was nearby in the shade, where it was much, much cooler. So the thermometer was accurate, but so was the cricket. I just wasn't matching the two sources of information. So try to get the thermometer as close to the cricket as possible. Sometimes you'll see that the cricket chirps go up and down in frequency. And one thing that you can do to compensate for this is to count them within a 14-second interval, wait a minute, count them again, wait a minute, count them again, and do this several times with the same cricket, and then average your results. And if you do that, similar to what you see right here, you can get a very close approximation of what the temperature is. Even if a single measurement may not be right on, the average is usually much, much closer. There are a lot of animals that sing and can make noises very, very similar or reminiscent of a cricket chirping. So be careful you're not getting confused by cicadas singing, katydids that sort of make a hammer-like noise, chipmunks, and of course all kinds of birds. Remember, there are always these aberrant individuals, and usually the temperature approximation that they're giving is lower than what the actual temperature is. And once again, that's because they tend to chirp for a few seconds, pause, chirp for a few seconds, pause, and sort of do that, so you don't get the full complement of chirps. Or they may go up and down in frequency, but I talked about how you can take an average to try to compensate for that. Or some of them just seem to be very lethargic chirpers. And this may be because they're either young crickets or maybe they're old crickets, maybe they're scared, maybe they're trying to send some type of different message. You know, it's kind of hard to tell. But with a little bit of practice, you can recognize which ones these are. And once again, by focusing on those that have a very steady cadence or a very steady beat, you can get a pretty close approximation of what the temperature is. And so that's it for this particular video. Once again, this is a part 2. If you want to see part 1 where we sort of answer the initial question, can crickets really tell the temperature? I'll leave a link to that video down below, and there should be some place later on that you can click on and get to it if you wish. Once again, if you like these videos, please hit the like button, subscribe, leave any type of comments. Otherwise, until the next video, have fun exploring nature.